Welcome again. I thought I'd be making one single video for the whole lab, but some nuisance happened and I had to stop recording altogether. So let's take you through the brief overview of our lab, climate literacy labs, and then you will be looking at carbon cycle. Okay, so as usual, you should definitely you should watch the six
Hello,
minute
class.
video from Mila. Then you'll go to the section one and follow all the instruction here. Then the type of question, fact based as always. The fact based question means the question is already there exactly the same way it's asking, so you need to answer it accurately. Synthesis based question, the question is already there but not exactly the same way you'd want, but you can process that answer in your mind by looking at the description. And the hypothesis based, the question is not there, it's more of a general idea of any topic, of any theme. So now look at the section 2, global carbon cycle, and I've already discussed that in the presentation. So all you need to do is to identify two sources of carbon in the picture, like which two is the source and which two is the sink. Two source and two sinks, so that will give you full marks if you can do that. Then question 2, where did the 9 petagrams of carbon emitted in the atmosphere by anthropogenic activities in 2010 end up going? So this 9 petagram, why this red 9 petagram carbon went, you can just track those red marks and you can answer this question. I've discussed that in my presentation as well. So, and in here as well, I guess there's some description about that, but the idea is you must watch my presentation video, which will help you to answer this question definitely. So if you didn't do well in these two questions, that means you actually didn't watch my presentation video, and I can't do anything about that. It's up to you if you don't want to get any marks. So the class overall is been doing good. So and I've already seen few of you already submitted your lab well ahead of my video. So it's evident that you already understand that this lab is already very easy for you to answer without even looking at my presentation or any video or any instruction. So that shows how easy this lab is. So please make sure you allot sufficient time for this lab, otherwise you will have a hard time. So please make sure. Then let's talk about section 3. I talked about that as well, the overall cycle. So the question is asking, one moment, sorry, watch this video. From where the wheat grass grating the carbon that is enabling it to grow. So watch the video here and answer those read those description. You will be able to answer this question 3. So question 4, um, to answer that question, I guess from slash and burn, you need to open these uh, and study those things, and then you need to study Amazon deforestation. You can see the deforestation cycle. So if there's any link, all you need to do is to click on that link. It could be either another website, it could be either a picture or Google Earth file or Microsoft Excel file. You need to analyze them and answer the question. So you can see the general trend in the Amazon. So at the beginning in 2000 it was more greenish in this area. Now you see during 2010 or 2012 it's almost there's nothing. So you see at the beginning it was really green. So that shows how deforestation is going in Amazon. So answer your question based on that. Section 4, how did the amount of carbon absorbed by the hydrosphere compared to the amount of carbon released by the hydrosphere in 2010? So you can see the amount of carbon absorbing by the ocean is more than it's releasing. So overall, it's actually taking in carbon and working. You already know that that uh, is an evidence that ocean is actually working as a sink for carbon. So section 5, I yeah. So I've already discussed with you about these. The coal-based power plant is more, and they emit more carbon dioxide here. So you can see there is a plant in Georgia. So this is the cooling tower, and you will, if you look at the description, you will be able to answer that question. And at the same time, there is a diagram how the cooling tower works. So there is some water injection, cool water and warm water. So water plays around this region. And you need to answer your question based on the analysis of these three graph. Mm, I don't need to answer that for you as well. So that's been easy here as well. Okay, follow the description question. It will be easy, I believe. And then I discussed these global budget. And if you look at the description, you can relate to my description that I did in my presentation video. The overall carbon, you see the trend, the overall carbon releasing, the carbon loss or release in the atmosphere is increasing in the form of land use, in the form of fossil fuel burning. And at the same time, because of that, the atmosphere, lithosphere, I mean ocean, terrestrial biosphere, atmosphere, they need to take up those carbons. So the more you are losing your carbon from your process, from coal plant, from fossil fuel plant, whatever it is, the more the atmosphere has to adjust with that. So that's the idea. So answer the question. um, then there is an Excel file for carbon dioxide emission from 1959 to 2014. So follow, open that, download that file, open it, and follow these instructions to answer your question. So these three instructions will help you to answer the question 9 and 10. So then you see, after that you'll have to go for question 11 and 12, and there is a Google file, Google Earth file. You need to click on that. That will download the Google Earth file here. So all you need to do is to click on that. It will be open on Google Earth. So okay, so if you look at that in here, so you need to adjust the Earth view so that you can see everything in the Earth. So I need to, you can adjust by clicking in here, you can see, and then you can click that and make it straight. You can click in, it will be even straighter. So if you look at the 1950, so there's a data for 1949 to 2009. So if you look at the 1950, then if you look at the overall, the whole world, you see there's some activities in here. I don't know what the country is. Let's see, let's move forward and see there's no activities in this region, the China, India, and Bangladesh. There's no such activities during the time. But if you go forward more and more, now you see here's the USA, the mighty United States of America. So okay, so you see there are lots of activities were there during 1949. So that will help you answer some of the question. And if you move the slider here, you see during 2009, or the overall 2009, the overall activity just in 2009, this is what US did. And if you look at in China, I guess you see the place that you saw in 1950 had no activities whatsoever. Now you can see it's full of activities for carbon dioxide emission. So less activities in this part, in this region of the world, in the African region, very less activities in the South American region, few activities in the USA, but China, the Asian countries, they actually increased a lot in this sector. So that's the idea of this Google Earth file. It is based on them. And so who emitted most of the carbon during 1950, then what countries were the top emitters, top two emitters in 2014. So country level carbon dioxide emission in 2014, if you open that file, that will give you a list. You can answer based on that, and that's really easy. So let's focus of the carbon sinks over time. So if you look at this one over here, from 1959 to 2010, carbon dioxide, carbon uptake by the atmosphere, ocean, and terrestrial biosphere. So if you look at these, follow this pattern in here, you can see the ocean gradually, the blue line gradually took more and more carbon dioxide. I mean carbon, not carbon dioxide, more carbon, made carbonic acid or whatsoever. Then there is a difference in the atmosphere and terrestrial biosphere. You see, when the terrestrial biosphere took less carbon dioxide, the atmosphere has to cover that. So they worked hand in hand. So they actually worked hand in hand. So they are related with each other. So there will be some question based on that. What's been the trend? Carbon dioxide from 2005 to 2014. You need to compare this region with this region. So just follow the trend and answer based on your understanding. And then there's for the section 7 for question 15, that will ask you carbon dioxide, if carbon dioxide is a well mixed gas or poorly mixed gas. To understand that, you need to click on the CO2 2010. If you click on that, it will download another Google Earth file. I'm gonna open that in here. Okay, so let me adjust that again by doing this. And then for now, okay, so what do you need to do? Just make sure in here, uh, you see when you're working on Google Earth file, uh, most of the time when you download a new file and open it, the previous one will also be there. So you see we worked on carbon dioxide emission 1950 to 2010 before, so I don't need that right now. So since I'm working on carbon dioxide 2010, I can uncheck this previous one. So if you uncheck that, that would be really easy, but really good for you to understand this question. Then it will say you to dash 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 look at the northern hemisphere, southern hemisphere. Mhm. Okay, so let me take you here. Just let me take you to the North America and South America. That will help you. So this is the Northern America and South America. So all you need to do, click on that and play the slider. So right now the carbon dioxide concentration in ppm is like this. From this diagram you see carbon dioxide is not concentrated in a tiny in a specific particular area. It's been spread out. So even if you play the animation here, you can see the change in color, but you see the change is uniform. You see it's getting more orange or more red, but whenever the change is happening, the change is uniform. That means carbon dioxide is evenly distributed. You can answer the question if carbon dioxide is a well mixed gas or poorly mixed gas. Then you look at the section 8 that asks you why did the carbon dioxide didn't go down even after the clean air act. You can answer that. I already told you about that in my presentation. Then section 9, follow these. Yeah, so Identify one places across the globe where there is a tropical forest, temperate forest, and boreal forest. So you already know that in my presentation slide, I already have those things mentioned there. Tropical forest is typically in the equatorial belt. You already know that temperate forest is in the mid latitude, and boreal forest is above that, like exactly around near the pole actually. You know that boreal forest is in Canada, so you can understand that. What you need to do, just follow my instruction in the presentation, as well as try to google them, what tropical forest is, the example and other stuff, and understand the type of the question, type of the forest, and type of them, how they perform. And which of the three forests do you think is the largest carbon sink, and why? Which forest absorbs more carbon? Sink means the absorption of carbon, right? So, which forest should be the largest carbon sink? So, if you look at these three types of forest, you can see the tropical forest is the evergreen one. The highest amount of green or highest amount of tree are there in the tropical forest. So, I know you all know already that tree is a really great source. I mean, sorry, great sink of carbon, because tree absorbs lots of carbon. Tree take in carbon dioxide. So naturally, among these three, the tropical forest should be the one you will be answering. Then there is a question about NPP. I told you I will be talking that in here. So in part one of this level on the green plants, okay. So NPP means net primary production, positive values of NPP. So NPP is related to the carbon intake and carbon emission. So if you look at the positive NPP, which means that more carbon was absorbed, absorbed by the sink, then was released by the respiration. So NPP is counted by the intake minus outtake, intake minus release. So if you take more and release, if you take 100 and release 80, that means if you see the difference, 100 minus 80, that is plus 20. That means plus means that more being absorbed. And if you take 100 and if you had to release 120, or all the process released 120 altogether, that means 100 minus 120 means minus 20, which means the net product primary production NPP value is negative, which indicates that there is more release in the atmosphere than it could take, than the whole process could take. So which forest have larger positive values of NPP each month? So if you look at the forest as well, so the more green space you have, the more you can take, right? So the more you add to the forest, the more it will take. That means the more it will take, the difference between the intake and the outtake will be more positive. So definitely tropical forest had that advantage, have that advantage of getting positive NPP. And if you look at these as well, there's another Google Earth file, so let me open that for you. You can see that in the video, in the animation here. So what we'll do, we will uncheck the previous one as well, just work on the 2010 net primary productivity. Okay, so you see, okay, okay. So if you look at the this region in the, just let's talk about this region in the, this is, you see, this is in the equatorial belt. So if you just move the slider, you see the green means positive. You see, in a region, in this region at least, it's always green. Let me play the animation here. You see, Other regions in being changing, but some portion of this part has always uh, have positive NPP, which means they have more forest throughout the year of 2010. And if you look at the USA, you can see, since USA have temperate forest, you already know that from the presentation. USA had temperate forest, Canada has boreal forest, so you can see that in here. So temperate forest, that means it doesn't have that forest all over the year. So to during spring season you will get to see positive NPP. Other than that, during winter or other time, there is really less tree. Even if you look at the Canada in here, you can understand the difference. You see USA tend to show more green to certain time of the year. Even you see in the Canada, but what it does, it loses it all. But USA have that for a longer period. Even during this time of the year, even during the November, you can see there's some greenery, at least in this region where we are living right now. I believe, I assume you all live in Georgia right now. So you see this region has at least some greenery. All other region, like during that time, during November or December, you probably saw some snowfall in those region as well. But this region had the extreme weather, extreme cold, probably during the December or January, right? So now even November also had some positive NPP during in this region, because this region in the USA is the main green region, I can say. Most of the greeneries, most of the woods you can see in this particular region of United States of America. So that's one another thing, and you can answer your question 1920 about based on that. Then, which of the three forests do you think is the largest carbon sink and why? The same question, question 18, question 21. Answer it based on your understanding. Then definitely study this tree table, like this picture. Study, read the description here, read it, and then study this table, the carbon sequence source in biomes, whatever it is, just study them, which will help you to answer question 22 and 23. The answer is already there. So if you don't study that, there's nothing I can do for you. So then the final one, I guess. No, the second final. Okay. So question 24, follow the description here. This is a hypothesis question that will be based on the overall idea that I've been talking about so far. Then there is a graph of carbon dioxide emission concentration at Mauna Loa station, Aloha, and ocean carbon dioxide. So if you look at the hot Mauna Loa in here, open that. I'm gonna open it. Oh no, let's open it now. So this is the Mauna Loa, and this is the station Aloha. So let me uncheck the previous one. Okay, so this is the Mauna Loa Observatory, and this is the station Aloha. So the question, let's go to the question. So if you look at this graph, you can see the carbon dioxide concentration at Mauna Loa, the gray one, has been increasing, as well as the carbon dioxide concentration in the ocean had increased. The trend is actually similar. So carbon dioxide in Mauna Loa increased, as well as the ocean carbon dioxide intake had been increased. So the idea is really simple. So if you see now, if you look at this graph is talking about the pH. You, I believe you studied that pH scale in lab 3. So if you look at the pH scale, this one, The 7 pH 7 means neutral, close to neutral. I mean neutral definitely. And the water that we drink, the milk that we drink, they have around six. Like if you look at the milk, it's between 6 and 7. So milk is little bit acidic, but not acidic definitely. Human blood, human blood is, you see, 7.35 to 7.45, little bit alkaline. Seawater is even more alkaline because you can see there's salt, baking soda. So these are the, if you go up in the pH scale, it shows that the water or anything in that scale that you measure is actually getting alkalic. If you go down in the scale, that means it's getting acidic. So if you look at your battery, car battery, the acid that has, that is acidic, and this in terms of scale, that's close to 0 and 1. So so 7 is basically neutral. So if you look at this graph in here, and in the, if you look at these graph, compare that with this one, you see the carbon dioxide concentration increased overall, the in Mauna Loa, as well as in uh, ocean as well. So the more carbon dioxide gets into the water, the more, you see, the water pH, the more it goes down. The pH goes down from 8.12 to 8.07. So if you look at the pH scale, so this pH is going down from this to this direction, right? So it's going to this direction. So that means water is naturally, the ocean water, sea water is 8.1, and that is getting towards the acidic section of the pH scale. But if you look at the final one in 2010, that is still 8.08. So although the pH scale is getting reduced, going towards the acidic portion, but it's very far from being acidic, right? So it is still alkalic. And so there's no way you can say that ocean water is getting acidic. Ocean water is nowhere near the acidic section of the pH scale, but the direction is that way. And it's also true, and it's also impossible for ocean water to become completely acidic, almost going to pH of 0, 1, 2, something like that. It's really impossible. uh, but the thing is, the direction is towards the acidic, but the bottom line, the ocean water is not getting acidic, it is still in the neutral or alkalic zone. So there's a question about that. Question 25 answered that, and that is the final question. Then you will have to answer a brief description of these three research questions. That's all for this lab. I hope it will help you. So all the best, see you next week.